starting with field data planning, where you're planning the mission data, technology, and workflow. Now, there are different approaches for identifying the mission data required to support your project, including performing an informal or a formal needs assessment. A formal needs assessment is just that, contacting your clients, assessing their needs, and then documenting that process. But sometimes it can be informal as well, where you're just simply emailing them and getting a reply back, or even more informal, where you're calling them on the phone or in a meeting and you're interviewing them and writing it down. Now, if your needs assessment is that informal, I would suggest sending a follow-up email saying this is what we agreed upon to collect in the field, and if you want any changes, please send them to me by this date. That way you're still documenting the process. By using the informal process, you're still getting what you want, you're documenting the process, but the overhead becomes a little less burdensome for you and your clients. Now, once you identify your needs, then you need to collect both your operational and base map data. Your operational data is the data required to support the project. So, for example, maybe zones in which you're collecting data, or maybe there's some existing locations for water meters that you're going to update. So you need those water meters. Often, in addition to the operational data, you need some base map data as well. And that might include, for example, high resolution ortho imagery that you're going to use as the base map for the project. Last, as part of planning the mission data, you need to inspect the site. You can do this in person and or virtually. And that's a really great thing about Google Maps and Google Street View, for example, is that before, if I had a project maybe in the valley, I had to drive down to the valley to inspect the site before I ever started collecting field data. But now with Google Maps, I can go almost anywhere in the world to inspect a site. And then a lot of places in the world, I can move to the street view where I can actually walk around the site. And you can learn a lot about the data you're going to collect just by inspecting the site before you go down there and start collecting the data. The next step in the field data planning phase is to plan the mission technology. And this includes a whole range of technologies. Sometimes we refer to this as your technology stack because you're piecing together different technologies to get the outcome that you want. So, for example, selecting your GPS hardware, which might be a survey grade Trimble GPS receiver, or it might be as simple as your mobile phone. You need to have a data collection app because we're not just collecting the location of things, but often we're collecting attribute values as well. And so ESRI has an app called Field Maps, but there are other apps out there, including, for example, the open source form.io that you can utilize to collect your attributes and any attachments and or photos. You need to think about your network and whether you are going to be collecting data real time in the field and posting it, for example, to a cloud service via a mobile data network or a satellite network, or whether you're going to be collecting data in the field and then when you return to a Wi-Fi network, uploading the data. You need to think about your data storage, whether you're going to be storing your data on a hard drive, on a cloud drive, or on external drive. And often I'm mixing up a couple of these to use one as my primary storage and another as my backup storage. Once you're back in the office, we often need to assimilate the data, and we need some type of desktop software to do that. Of course, we use ArcGIS Pro here in the ACC GIS program, but you could use an open source product like QGIS. And then last, you need to think about the technology required to create your final deliverables. And you always need to be thinking about the purpose, the beginning, but also the end, what you're going to be delivering. And it might be a PDF map series. And of course, that drives your technology stack, or it could be a real-time interactive dashboard accessible via a web browser. So depending on your mission data that you've identified through your needs assessment, you need to identify a stack of technology that's going to support the workflow for collecting the data and satisfying your purpose for the project. Our final step in the field data planning phase is to plan the mission workflow. And so that might be simply as just writing out and drafting what your workflow is going to be. If you look at the image on the right, you can see that I have a logbook in which I've written out 5 steps for my tree survey workflow. And so once you know your workflow in general, you also need to pre-select your data collection routes and areas. And again, back in my logbook, if you look at the right side, you can see that I'm collecting tree survey data at the South Austin campus. And so I've sketched out the location data, the intersection of Menchaca and West Stastny Lane, but also the general location of the buildings and the area of interest, and then my flow that I'm going to walk around the campus to collect all the buildings. It's important you do this because you want to make sure that you don't have any gaps or overlap in your data collection, because gaps, of course, means you have to go back out there and collect the data, and overlap, of course, means you're not being as proficient as you could be. Last, I like to create a prototype or pilot to test my workflow, train my data collection, and potentially perform some preliminary analysis to make sure the data I'm collecting in the field will satisfy the analysis and purpose of this project. Now, the difference between a prototype and a pilot, I prefer a pilot where you're actually collecting a subset of data in your area of interest. This is the best way to troubleshoot your workflow and make sure that you need to revise certain steps to get the data that you need. But sometimes you can't do that. Sometimes, for example, I mentioned a project in the valley. You can't go down there to pilot your data. And so sometimes I'll actually prototype the data. So I'll impute or make up the data, or maybe collect data around where I am that is a stand-in for the data I'll actually be collecting in the field. And in doing that, and there's only way to test that workflow is to actually do it in the field, you can really save yourself a lot of time and make sure you collect all the data that you need. The second phase in the field data collection workflow is configuration, where you're configuring the mission schema, settings, and procedures. And we'll start with the mission schema, which is really just the data structure, right? Where we model our data schema, for example, utilizing an ER diagram like you see in the lower right-hand corner, or maybe it's just a data dictionary where you're listing out all the fields and the field types that you're going to be collecting in the field. Now you need to specify your feature class geometry type. Are you going to be collecting points, lines, or polygons? What attribute field names and the data type for the values you're going to be collecting in the field? And then, of course, we can enhance our geodatabase structure by using advanced geodatabase objects like feature subtypes to subset our features, or attribute domains to restrict the values within a particular field for the data we're collecting. If you're going to be collecting 1,000 locations in the field, but 95% of the locations you collect are going to be of this same category, for example, maybe you need to set default values. And then, of course, depending on the type of data you're collecting, you might want to set up relationship classes. For example, a lot of field data collection might be inspections, where you have a particular feature that you go out many times to inspect that site. So that's one feature to many inspections. You need to set up a relationship class to support that data relationship. Or if you have attachments or photos, again, that might be one feature to many attachments or photos, and you need a relationship class to support that. The second step in the field data configuration phase is to configure the mission settings. And that includes the GPS settings, but also configuring your map. We'll start with standardizing your GPS settings. There's a lot of settings, both in your GPS, but also in your software, that you can set to standardize the data you're collecting in the field. So for example, you could enable or disable GPS averaging. If you disable GPS averaging, you can collect data more quickly, but it might not be as accurate. If you enable GPS averaging, it's going to take longer to collect each location, but each particular location might be more accurate. So a lot of times when we're selecting our GPS settings, we're balancing proficiency over data quality. You need to set your GPS height, which is the location of your GPS receiver. And once you have that, then the software often subtracts that height from your altitude to calculate the elevation at the location where you're collecting your position. You need to set settings like minimum accuracy, or your estimated positional error, which is your aggregate position dilution of precision. And you need to be thinking about your photo size. A lot of these cameras can capture images that are much higher resolution than we need. And of course, that will balloon your data storage. On the other hand, you need to make sure that you're capturing enough resolution that back in the office, you can interpret the photos as needed to support whatever your purpose is. In addition to standardizing our GPS settings, we also need to configure our map, and that includes adding our operational layers that we identified in the planning stage and choosing our base map layers. You might want to add bookmarks so that you can quickly move around your map where you need to be. And then also you need to consider whether you need to add offline areas that if you're going to be collecting data in the field, and for example, you don't have a mobile data or satellite connection, maybe you need to add offline areas so those maps are automatically downloaded to your data collection device and you have them in the field. And then when you come back in the office, you can use Wi-Fi to upload your data collected. The last step in the field data configuration phase is to configure the mission procedures. And that includes your field procedures, but also your office procedures, where, for example, you need to identify how you're going to store and maintain your technology. So, are you going to charge batteries every night? You need to have that written up in your procedures to make sure that you don't come into the office the next day and somebody didn't charge the batteries so you can't go out in the field. You need to have procedures for validating your data so that you make sure all the data you collect in the field is usable. You need to have procedures for assimilating the data. Maybe you're collecting data in one coordinate system, for example, WGS 1984 geographic coordinate system, and then in the assimilation phase, you want to transform it to a local state plane projection coordinate system. And then also you need to identify a procedure for backing up your data. And I always tell my students when they ask, when do I need to back up my data? It's when you'd cry if you lost your data. And in field data collection workflow, it can really lead to some tears because going back in the field might be a 6, 8 hour drive or even a flight away. So you really want to make sure that you have good backup procedures so that you don't lose your data. In addition to documenting your office procedures, you also need to document your field procedures. So that means not just the draft workflow you came up with in the planning stage, but actually formally documenting the workflow for collecting consistent spatial, attribute, and any attachments and photos. So that if you have multiple individuals collecting data or you're collecting data over a really long time, you want to make sure that the data that you're collecting at the beginning or with multiple teams is as good as the data that you're collecting at the end of the project. And last but not least, of course, you need to identify any feature and or project level metadata. That is the information that describes the individual features in the overall project. So later on, if it needs to be updated, somebody can open up the project, they can understand what the project was trying to achieve and actually understand the individual feature attributes and maybe the accuracy or explanation of the field values that were collected. If you look over on the right, I have a statement of work document for an ACC tree cover service learning project. And that's the same type of documents where we're formally documenting workflows in the ACC GIS program. And it's the same structure I use when I'm working outside of ACC GIS on contract work or on setting our interns up for work with other institutions.